Hello students, welcome to SB Math Stat Physics class. Today we will start episode 1 part 7 of vector algebra. In this class we shall do some problems based on scalar product or dot product of two vectors that have appeared in JEE Main or JEE Advanced exams. Before proceeding to the number 1 problem or number 1 question, I would like to explain something more about projection of a vector on a vector. ধরো এইটা হলো বি ভেক্টর, এই যে ভেক্টরটা এটা ধরা যাক হলো বি ভেক্টর, আর এই যে ভেক্টরটা আছে সেটা হলো এ ভেক্টর. Let this vector be b vector and this vector be a vector, and we need to find out the projection of a vector along b vector. What you have to do? You have to draw a perpendicular from the head of a vector on b vector. Okay, so let this be the perpendicular drawn from the head of a vector on b vector. Then I have told you that this vector is the projection of a vector along b vector, or component of a vector along b vector, or the resolved part of a vector along b vector. And in the previous section I have told you that this vector is a vector dot b vector by mod b vector squared this scalar multiple of b vector. Okay, this is the scalar that have to be multiplied with b vector to get this vector. Now, number 1 point of observation is this quantity may be negative or may be positive. Why? If a vector makes an acute angle with b vector, then a vector dot b vector is positive, because theta, if theta lies between 0 and pi by 2, exclusive of pi by 2, then a vector dot b vector is positive. But if a vector makes an obtuse angle, suppose a vector is here, then you have to draw a perpendicular, but according to this you have to take this angle, right? So then a vector dot b vector is negative. So then, as you see from figure also, this vector the projection becomes this vector. Okay, right? Now if you take the magnitude of this scalar, okay, only the absolute value of this scalar, then this magnitude and this magnitude become equal, দুটোরই লেন্থ সেম হয়ে যাবে। এটা খুবই স্পষ্ট ব্যাপার। এবার যদি তোমায় বলি যে বি ভেক্টরের অ্যালংয়ে, মানে এই ধরা যাক এখানে, ধরা যাক সাপোজ প্রথমে এই প্লেনেই নেওয়া যাক, প্লেন অফ দ্য বোর্ডে কতগুলো ভেক্টর আছে যার প্রজেকশন অন বি ভেক্টরটা এই ভেক্টর হয়, অথবা এদিকের এই ভেক্টরটা হয়, সেটা কি ইউনিকলি বার করা যাবে? বুঝতে পেরেছ? The question is how many vectors are there on this plane of the board which has the same projection on B vector. Okay, same projection means this vector remains same. How many vectors are there? Suppose in this figure, if you take A vector to be one of the vector, then is a vector unique, or you can find many more vectors. Look, if you extend this perpendicular, suppose this is the perpendicular, then see, observe that if you take this vector, then this vector also has the same projection along B vector, right? Because the perpendicular, so this is the same vector. So if you take this vector, then this vector also has the same projection along B vector. If you take this vector, this vector, this vector, this vector, so all these vectors have the same projection. Okay? And if you take this side also, then if you draw a perpendicular here, then also you find infinitely many vectors which has same projection along B vector. Okay? So if you know the projection, the length of the projection or this vector, then you cannot find out a vector uniquely. Even if you rotate this vector, okay, with the same angle, this angle, about this axis, then all these vectors have the same projection along B vector, right? তাহলে আরো অনেক ভেক্টর পেয়ে যাচ্ছ। So for a given projection, there are infinitely many vectors. Okay, this should be kept in mind. এটাকে কিন্তু সবসময় খেয়ালে রেখো। Now let us do question number 1 that have appeared in 1993 JEE Main. Actually at that time JEE Main was called XI&XII. The question is in your screen. Question states that there are three vectors, A vector, B vector and C vector, and you have to find out a vector that is on the plane containing B vector and C vector. This is the number 1 point, and number 2 point is whose projection on A vector has a magnitude root over 2 by 3. Has a magnitude, remember, 2 by 3. Okay, so let us find out. As I have told you just a minute earlier, that there are infinitely many such vectors. Even if you don't know this feature, you can proceed without knowing that feature. Okay, so we know that a vector on the plane containing B vector and C vector is, name it, alpha vector. Okay, so alpha vector is a vector in the plane of B vector and C vector. So I have told you in previous lectures that alpha vector can be expressed as a linear combination of B vector and C vector. That is, you can find two scalars lambda and mu such that alpha vector equal to lambda B vector plus lambda B vector plus mu C vector. This means that this can be written as, this is lambda, this is mu, So this is lambda plus mu I cap. Okay, this is lambda, this is mu. So 2 lambda plus mu j cap plus, okay, this is lambda, this is mu. So you can bring minus out. So this is lambda plus 2 mu k cap. Okay. So now our task is to find lambda and mu. Now this alpha vector has projection on a vector or along a vector, whatever you call, and that projection has a magnitude 2 by root over 2 by 3. But we know that the length of that projection is, what is that projection? What is the length of that projection? Alpha vector dot a vector by mod a vector. So that is the length of that vector, but that length may be negative or positive, and even here you are told that this has magnitude root over of 2 by 3. This means that this is plus minus root over 2 by 3, or you can write mod of this is equal to root over 2 by 3. So remove mod so that you get this. So what you have to do now, find out this. So what is alpha vector dot a vector? This is 2 lambda plus mu minus 2 lambda plus mu, and this is minus lambda plus 2 mu, right? This is alpha vector dot a vector divided by mod a vector. Mod a vector is 2 square plus 1 square plus 1 square, means 4 plus 1 5 plus 1 6, root 6. Okay, so this is plus minus root over 2 by 3. Okay, remember this is alpha vector. So always this is a very important thing. This is alpha vector. Okay, so keep this in mind, because after finding the value of lambda and mu, we have to put those values over here, and that will give the answer. Okay, so from here so this is 2 lambda minus 2 lambda, cancel out, so this is minus lambda. Okay, and this is 2 mu and this is minus 2 mu, that cancel out, so you have minus mu. And if you bring root 6 over here, root 6 means root 3 into root 2, root 3 cancels out, so root 2 into root 2 means plus minus 2. So you have two cases. One is lambda plus mu equal to minus 2, and other is lambda plus mu equal to 2. Okay, to start with any one, okay, any one of the case. So suppose you are taking this case, lambda plus mu equal to 2, but if you take lambda plus mu equal to 2, there are infinitely many lambda and mu for which lambda plus mu equal to 2. So you have infinitely many answers. But since you have to choose the answers from the 4 options, so now check that out. Now if you concentrate on option where the coefficient of I cap is 2, then you can take lambda plus mu equal to 2. So this is lambda plus mu equal to 2, and now take the first options. There the coefficient of j cap is 3, so 2 lambda plus mu is 3. right? Now solve it. So this is 3, okay? Now you have to find the value of this. For that, solve this. So if you do this minus this, you have lambda equal to this minus this equal to 1. So you have mu also 1. So then this becomes 2i cap plus 3j cap minus 3k cap. So any option which has this as answer, any option which is this is one of the correct option. Since option A gives exactly this result, so option A is correct. And if you go to option B, okay, so there you have 2i cap plus 3j cap, okay, plus 3k cap, but you cannot, if you take 2 plus lambda, 2 lambda plus mu equal to 3, then the value of this becomes 3, so this is minus 3k cap, so option B cannot be correct, okay. And what about option D, okay, and option C? In that case, take, since the coefficient of in C, the coefficient of j cap has been taken as minus 1, then you have to take this as minus 1, okay. If you take this as minus 1 and if you now subtract, so this is lambda, so this is this minus this, so this is minus 3, and if this is minus 3, then this must be 5, okay. And so I cap, the coefficient of I cap is 2, okay. Coefficient of j cap is coefficient of j cap, you have to take coefficient of j cap as 1, because you want to check whether option D is correct or not. So then this minus this minus this minus this means minus 1. And if you take lambda equal to minus 1, then mu becomes 3. Okay, so then this is 2i cap, this is 3j cap, no, this is plus j cap, and what about this? This is minus 1 plus 6 means plus 5k cap. So you have 2i cap plus j cap minus plus 5k cap, minus 5k cap, 2i cap plus j cap minus 5k cap. But this is not option D, so option D cannot be correct. Now come to option C. Here the coefficient of I cap has been taken as minus 2. That means you have to take this as the case and take this, and again take the coefficient of j cap to be minus 1. You will find the value of lambda and mu, so that the coefficient of k cap will become 5. So option C is, then option C is also correct. So the correct options for this question is A and C. Okay. The method that I have discussed is very tedious, cumbersome and time consuming. So how to save time? Look, if alpha vector is a required vector, then you must have alpha vector dot a vector divided by mod a vector equal to plus minus 2 by 3. And what is mod a vector? 4 plus 1 plus 1, 6 means root 6. So you must have alpha vector dot a vector equal to plus minus 2. And now just check from the option, just do this dot product. If this dot product comes out to be +2 or -2, then this is a correct answer. And just repeat the same process for B, C and D, and you will find that option A and option C matches with this condition, and option B and D do not match with this condition. So A and C, option A and C are the correct options. So this method you must opt. But how would you know that you should do this way? You should do the problem in this manner. I have told you, since there are infinitely many vectors which has the same projection on a vector, so by doing the problem procedurally, you will find the method very tedious, cumbersome and time consuming. So you must opt this method. Okay. Now one more thing, I have found that in many books, alpha vector has been taken as B vector plus TC vector. Okay, and then they have done this and find out the value of T. Okay, and then putting the value of T, they have obtained that option A and C are correct. But the method is completely wrong, because expressing alpha vector in this manner is incorrect. Since alpha vector is coplanar with B vector and C vector, alpha vector can be expressed as a linear combination of B vector and C vector. That is, you can find two scalars lambda and mu, so that alpha vector equal to lambda B vector plus mu C vector, that which I have done in the previous method. Okay. Suppose, but one more thing, suppose the one option, suppose instead of D, this option, you are given -2i cap minus 5j cap plus k cap plus k cap. Now if you do put alpha, this vector instead of in place of alpha vector, and you will find that alpha vector dot a vector is +2 or -2, I don't know. Okay, just check out. So then in that case, A, B and D, okay, D option would have been correct. But if you have taken alpha vector equal to B vector plus TC vector, then you cannot obtain the option D. Now let us take the question that is appearing on your screen. The question states that A vector, B vector, C vector are given, and the projection of B vector on A vector is A vector. What does this mean? Projection of B vector on A vector is B vector dot A vector by mod A vector squared A vector, and this is equal to A vector. This is given. This means that this is equal to 1. This means that B vector dot A vector equal to mod A vector square. So B vector dot A vector equal to mod A vector squared. What is B vector dot A vector? This means that B1 plus B2 plus 2, okay, equal to what is mod A vector? Mod A vector is 1 plus 1 plus 2 means 4. So this is 4. So this means that B1 plus B2 equal to 2. Okay, so this is 1. Now again A vector plus B vector is perpendicular to C vector. So this plus this means B1 plus, this means that B1 plus 1 into 5, this plus this into 1 means B2 plus 1 plus this plus this means 2 root 2, 2 root 2 into root 2, 2 root 2 into root 2 means 4, 2 root 2 into root 2 means 4, so this is equal to 0, means 5b1 plus b2, here this is 5, this is 1 6, 6 plus 4 10, equal to minus 10. You can solve 1 and 2, equations 1 and 2 to get b1 and b2. And now what is mod b vector? b1 square plus b2 square plus 2 whole root. You will find that this quantity becomes 6. So option A is correct. Now take a look on the question that is just appearing on your screen. It is the same question or similar question to the first question that we have discussed. You are required to find a vector which has projection on C vector which is such that the magnitude of the projection is 1 by root 3. So if alpha vector is the required vector, then you have alpha vector dot C vector by mod C vector equal to plus minus 1 by root 3. But mod C vector, what is mod C vector? 1 plus 1 plus 1 over under root means root 3. So that means alpha vector dot C vector is equal to plus minus 1. Now just check the options. Now take the first option. So 4 into 1 minus 1 minus 4. So this is minus 1. So this condition is satisfied. So option A is correct. Since only one option is correct in this case, so option A is correct. So you don't need to check the other options. But just for your own concept, for the development of your own concept, check the other options also. You will find that no other option matches this condition. Okay, so only option A is correct. Now take a look into the next question. It is similar to the previous question. I think you can do the problem. Okay, so I am not proceeding any further. Now let us look into the next question that is just appearing on your screen. But before dealing with the question, I like to tell you that if a vector makes an angle alpha with the positive direction of x-axis, or in other words, if the vector makes an angle alpha with I cap, and if the vector makes an angle beta with the positive direction of y-axis, or in other words, the vector makes an angle beta with j cap, and if the vector makes an angle gamma with the positive direction of z-axis, that is, in other words, the vector is making an angle gamma with k cap, then cos alpha I cap plus cos beta j cap plus cos gamma k cap is a unit vector along that vector. That is, cos square alpha plus cos square beta plus cos square gamma equal to 1. Okay. So remember this feature we will apply in 3D geometry or in many problems on vectors. Okay. Now deal with the question that is given. Here the unit vector, here a unit vector makes an angle pi by 3. So alpha is pi by 3 with I cap and pi by 4 with j cap, means beta equal to pi by 4 and theta, that is gamma equal to theta with k cap, where it is given that theta is lying between 0 and pi, that is theta is the smallest angle between the unit vector that you require and with k cap. Okay. So now you have to find theta. So you know that cos square pi by 3 plus cos square pi by 4 plus cos square theta equal to 1. What is cos pi by 3? Cos pi by 3 is half, so this is 1 by 4. Plus what is cos pi by 4? Cos pi by 4 is 1 by root 2. So this is 1 by 2 plus cos square theta equal to 1. You can even bring this over here. So this is sin square theta. And 1 by 4 plus 1 by 2 is 3 by 4. Okay. So sin square theta is 3 by 4, means sin theta equal to root 3 by 2. Since sin theta equal to plus minus root 3 by 2, but you cannot take minus root 3 by 2, because if you take minus, then theta belongs exceeds the interval 0 pi. Okay. Now in 0 pi, what are the values? One value is pi by 3 and other value is 2 pi by 3. Now see the answer. The only one option matches with this option. So 2 pi by 3 is the correct answer. So option D is correct. Now consider the next question that is appearing on your screen just now. Here PQR is an arbitrary triangle and O is taken as the origin, and you are given this is equal to this equal to this. Now the question is about the point S. Okay, so what is S? S, is it the centroid, or is it the orthocenter, or is it the incenter, or is it the circumference of the triangle PQR? Okay, so just take these two relation, bring this over here, so and take OP vector common. So this is OQ vector minus OR vector. Okay, and from these two take OS vector common. So this is OR vector minus OQ vector. Okay, so this is equal to 0. So this is OP vector dot, what is OQ vector minus OR vector? This is RQ vector, right? OQ vector minus OR vector is RQ vector, and this is OS vector dot, this is QR vector equal to 0. Okay, so this can be written as OP vector dot RQ vector minus OS vector dot QR vector can be written as minus RQ vector. Okay. And now take RQ vector common. So OP vector minus OS vector dot RQ vector equal to 0. Right? But what is this? This is SP vector. So SP vector that RQ vector equal to 0. This means that SP is perpendicular to RQ. So in the triangle PQR, okay, PQR, so this is RQ or QR and this is SP. So SP is perpendicular to QR. When does this happen? This happens when S is an orthocenter. Even from one case you can even say that S is a circumcenter or in-center, or the other options may be correct. But since PQR is an arbitrary triangle, so for an arbitrary triangle, PS is perpendicular to QR can only happen if S is the orthocenter. So the option B is correct. Now take a look into the next question. The next question is appearing in your screen. The question is ABCD is a parallelogram. AB vector is given, AD vector is also given. AD vector is rotated through an angle alpha so that AD vector is perpendicular to AB vector. You have to find the angle alpha. Now, you have to find cosine of angle alpha, that is cos alpha. How do you proceed? Look, it is clear that alpha plus theta equal to pi by 2, where theta is the angle between AB vector and AD vector. So, alpha is pi by 2 minus theta. So, sine alpha equal to cos theta. But what is cos theta? Cos theta is AB vector dot AD vector by mod AB vector mod AD vector. But what is AB vector dot AD vector? Minus 2 plus 20 plus 22. So this is 40. So this is 40. And what is mod AB vector? 4 plus 100 plus 121. So 225. Root over 225 is 15 square is 225. So this is 15 into what is AD vector? 1 plus 4 plus 4 means 9. Root over 9 means 3. So 5, 3, 5, 8. So this is 8 by 9. But this is sine alpha. But you have to find cos alpha. Then what is cos alpha? So now what is cos square alpha? Cos square alpha means 1 minus sine square alpha means 1 minus 64 by 81. So this is 17 by 81. So therefore cos alpha equal to root 17 by 9, but there is plus minus. But cos alpha cannot be negative because alpha must be acute, right? So therefore cos alpha equal to root 17 by 9. And which option is root 17 by 9? That option is correct. So this is all about the problem.